DNA replication, and it all starts when the
Helicase?
Did you say it helicase or helicase?
Either one.
Helicase comes in and cuts the DNA open, kind of. This here is the topoisomerase, and this is keeping this long, invisible strand of DNA from coiling in on itself. So when the helicase comes in and cuts it, you have two ends. You have the leading strand and the lagging strand, and this over here is the leading strand, and the parent DNA serves as a kind of
base
for it.
Template?
A template for it. And so new nucleotides can come down. These are the single strand, what are they called?
The single-stranded binding proteins.
Binding proteins, that's what these are. And they kind of hold everything in place. You have to have a DNA primer go down first. RNA primer
sits there and is the starting point for the DNA polymerase.
And it has to come on the 3' end. So that's what this guy is.
Good.
So the leading strand is going to just follow the helicase right down and keep replicating. This is the
DNA
polymerase.
And that's what's putting the new nucleotides onto the old ones.
Very good.
And then this is the lagging strand, and it's traveling in the opposite direction of the helicase because it has to travel in the direction of the 3' end. So it has to go from this end to that end. So it's still being held open by the single stranded binding proteins. And so the primers are laid down in various different places instead of just one, like in the leading strand. And so it's replicated in various fragments and then connected together by the ligase, yeah. And so the ligase attaches them, and then DNA polymerase comes down and fixes everything up.
What fixes it up?
The DNA polymerase.
No, the primase. I'm sorry.
The DNA polymerase puts it all together,
right.
And then the ligase comes in and puts it all, connects those fragments.
The Okinawa
fragments.
Okazaki.
That word. Yay.